joy being in my home state, where I went to school and graduate school and taught at Stanford, taught at San Diego and Santa Cruz. I didn't teach at Stanford. Got my degree there. And just love being back, seeing the vegetation. It's my vegetation. I love it. One of the first experiences I had as a naturalist, I consider myself a naturalist these days, not a scientist anymore. I don't publish a lot. But I was walking in the chaparral.
Sorry to interrupt you.
That's all right. I'm going to put this, I need to put my laptop down somewhere, but this, is it okay if I put it on top of this laptop? Okay, let's see if there's an explosion. Maybe there'll be sex. I'm always hoping for that. Anyway, one of the first experiences I had with plants and plant biology was I was walking around my house in Del Mar and up in the chaparral, coastal sage scrub, and I remembered, I forgot who it was, but some early 20th century scientist, I think it was British, said, when you don't know what to do when you're in the wild, count things. So I was walking along thinking about counting, and I saw some cactus, this small coastal Pherocactus viridans or viridescens, I forgot which it is. Which is it? Viridescens. Thank you. And I was intrigued by them, so I said, okay, count. What should I count? So I started counting the ribs in the cactus. And first I counted them clockwise, and then I counted them clockwise, and the numbers were different. And then I found some very small baby Pherocactus and some quite large ones. And then later on I went to Anza-Borrego and found a giant Pherocactus. And so I looked at my numbers, and the smallest cactus, smallest Pherocactus had 5, maybe 3 ribs turning into 5. And then the next number where there were lots of cactus had 8 ribs, and then 13. The next, the really big ones had 13 or 21. So something about those numbers struck a bell. 3, 5, 8, 13, 21. What series is that? Fibonacci series. And it just, the word Fibonacci just came into my mind, because I had read it somewhere years before, but I didn't remember what it was. And then all of a sudden, I said, oh, the Fibonacci series. And then I started reading about phyllotaxy. I got really intrigued by this phenomenon, because it's universal. You can see it on pineapples, on pine cones too. The same numbers keep popping up. And I submitted a paper to Science about that in the cactus, and it was rejected. And then a couple of years later, somebody published it. It really pissed me off. Well, I'm not a vengeful person, but if I see the guy, I'll kill him. So anyway, I have been a botanist in a sense, because I've been intrigued by phenomenon that you can see in plants. And I'm still intrigued, as you'll see by some of the photographs I'll show in a few minutes. Well, first, the bad news. You've heard about the term Anthropocene. It means the era or epoch of human domination of the world, of nature. It implies that humanity has finally conquered wildness, has tamed nature. The Anthropocene means that we're in control, that everything is going to be domesticated. And finally, we will have hegemony, manifest hegemony over all life. Some people are gleeful about that. There are lots of people who really want people to dominate. They feel it's where we're headed, it's our destiny, like manifest destiny. Human exceptionalism is also our destiny. I hate it. So the Anthropocene implies an ultimate victory for mankind, not womankind. We have to use the word mankind over the wild. This is not good. Other people are depressed that Lord man may achieve total biological domination. But others call them dominators, actually seek human domination, seek human victory, I think are deluded. Because it means that every place on the planet will finally be domesticated, finally be safe, be tamed. And to be candid, I think that Emma Maris and Peter Kariva fall into this group. That's no secret, I've published that. So what does human domination mean about evolution? About the creation of new species by isolation and natural selection, and what does it mean about extinction rates? Has evolution ended? Sadly and simply, yes. Not for microorganisms, not for bacteria, maybe plankton, really small creatures, some insects are still evolving and speciating. But for larger creatures, the ones that you see in the field, mostly the animals and the plants, for practical purposes, speciation has come to an end, because speciation requires large, extensive areas that are relatively unperturbed for long periods of time. It takes thousands of years for a new species of large plant or animal to speciate because it takes isolation. One population usually has to be over here, another population in the next county or the next state. And that's not happening anymore because we're constantly moving things around and disturbing things. So I believe that speciation for most large plants and virtually all animals has come to a screeching halt and will remain that way until something very serious happens to people. I hope it's the people. Decades ago, I wrote a paper about this subject and pointed out that the evolution of new species of animals requires large areas. And I realized, I looked at the data and found that the smallest island on which speciation of rodents could occur was about the size of Cuba or Madagascar. Anything larger than that took a much bigger space so that isolation could happen. In a very small place, there's no such thing as isolation. Fortunately, insects and small plants can speciate over much smaller areas. But speciation also means the absence of human disturbance. We can't go messing things up because speciation takes hundreds of thousands of years to happen, and there can't be much disturbance during that time. But that's not the way the world is working now. And you'll be hearing from Paul Ehrlich talking about population and how population bomb is still exploding. I had dinner with Paul and Ann last night. Paul was my mentor in graduate school. In places like Gambia, like most countries in Africa, predators have been eliminated. People don't like predators because they have livestock and little kids running around. So when the population gets to a certain level, the human population, the lions, the hyenas, the leopards, are all wiped out. So Africa is now virtually devoid of large predators, except if you're a tourist and they take you on safari to the national parks, you see lots of predators. But that's the only place you'll see large predators. In Gambia, where the large predators have been eliminated, the baboons have taken over. And they form long lines in the savannah and reach out and touch the fingertips of the baboons next to them and form and do a sweep. This long line of baboons marching across the savannah, gathering up and eating every small animal they find. It's very efficient. They're vacuuming them up. So that's one of the things that happens when large predators are removed. And I do talk about animals, particularly predators, because I think they're very important in maintaining the diversity and integrity of ecosystems. If you remove the large predators, well, we saw what happened in Yellowstone when the wolves were removed. The aspen grew extensively, and then the elk came in, and they ate basically all the vegetation down to the ground in some places, including willows, so aquatic habitats too were destroyed. So when we remove these large predatory animals, bad things happen. So we need everything. We need plants of all kinds, trees and shrubs and grasses, forests, and we need animals. The whole ecosystem is required to maintain the stability and the evolution of new species in ecosystems. And that takes extensive areas. And there's other things that are causing disappearance of creatures. Pastoralism, particularly cattle and sheep. About 50% of the land surface of the area of the world are now dominated by cows and goats and sheep and pigs. And they eat everything. So if you're a botanist, you have not to like some of those creatures because there's no plants left. There's some good news. These dismal trends can be reversed in some places. How? Well, the formula that was developed by the Wildlands Network was the 3 Cs. The 3 Cs are large core areas, wild areas. You've got to have places where natural processes can occur without disturbance. They have to be chock full of native species, and they have to be the size of national parks or larger. Second, they have to contain large carnivores like wolves that protect the vegetation from overbrowsing and overgrazing by herbivores, wild and domesticated herbivores. The large carnivores are like the police in the ghetto. If you remove them, the shit hits the fan. Third, you need connections, landscape corridors. And of course, that's the mantra of the Wildlands Network we've been talking about for years, that if there's a lot of habitat loss and disturbance, then we have to build in connectivity to the system. And now, facing climate change and the imminent movement of plant communities or individual species and animals over long distances going mostly north in the northern hemisphere, mostly south in the southern hemisphere, we need extensive connectivity on the ground so these creatures can move. Otherwise, they'll run into highways and urban areas and large areas of farming and grazing, so that they'll be stopped. So if we want species to survive during the coming era of climate change, we need to have connectivity in the ecosystems so that they can move, assisted or not. I've had fantasies about loading flatbed trains with lots of dirt on them and putting plants on them so they can move north at the same rate as the climate's changing. Actually, I gave a talk in Washington one time, and on the back of an envelope, I calculated how fast plant communities have to move. This was 30 years ago to keep up with climate change. So I put a potted plant on the stage, right here, and every few minutes I would walk over and nudge it with my foot. Because I calculated that in a space of a lecture of 50 minutes, a plant would have to move several feet to keep up with the rate of climate change and the shifting of latitudinal and longitudinal lines. So it's really not trivial. Oh, are my slides on here? Oh, yes, they are. Okay. So now which computer should I use? So we need keystone species like wolves. We need foundation species. Now this isn't a term in wide use, but keystone species by definition are relatively rare animals usually, but they have a strong effect even though they're not very abundant like wolves. Foundation species are common but essential for the integrity of an ecosystem. For example, aspen. I happen to live in an area with lots of aspen. Aspen are a foundation species, just as important as keystone species, but not because they're rare, but because they're common. And they provide lots of resources for lots of other creatures, particularly cavity nesting birds. Neotropical migrant cavity nesting birds rely on cavities in trees to breed. And they provide a lot of insect food for birds and other animals. So foundation species aren't talked as much about as keystone species, but they're just as important. And of course, as I mentioned, we need native carnivores who police ecosystems, keep the herbivores from becoming so abundant that they consume most of the vegetation, which isn't good for plants. So let me show some slides here. How do I advance this with this? Which button advances? Okay, thank you. Yeah, that's good. I was in Africa with my family in August. I choke up when I think about Africa. I spent 2 years there. I was one of the early faculty at the University of Malawi, and I just love Africa. It's the source for me. It's where we evolved. We left 50 or 60,000 years ago, and we've populated the whole world and diversified into all the different races, so-called races we have now in that period of time, not very long. Here's a sand dune in Namibia. Is it up? Yeah. And this is an area that gets maybe 1 inch of rain a year and not every year. So there's hardly any plants. You guys would be miserable there. But I like deserts. I like the pristine elegance of nothingness, like a martini. So here's where the rocky desert meets the sand dune. Hardly see any plants at all. Whoops, did something wrong. Okay, so, that's my son, looking at one of the few plants. And this is near the coast of Namibia, where there's a cold stream, like the Humboldt Current in South America. A cold current comes up the coast, creates a lot of fog. And a lot of the plants there and a lot of the animals get their moisture from fog, not from rain. You know what this plant is? Yeah, it's my favorite plant in the whole world. I just fell in love with welwitschia. I don't know why. They're so cute. And there's two sexes. That's interesting. There's male and female cones. It's a conifer. I mean, just grokking that there's conifers growing in this desert that don't look anything like pine trees, but they have cones. So this is currently my favorite organism, actually. That's John Pierce, who taught at UC Santa Cruz when I was there, and we were roommates in graduate school. His wife, Vicki, was around too. That's my wife, looking at them. And that's welwitschia. They look like, you've seen them in your botany textbooks, they look like kelp growing out of some desert arroyo. And they have little cones that come up. Whoever would have thought? This is a euphorbia. I forgot the other name of it. That's my wife standing next to it. Giant euphorbias. Why? And not much else, some grass going around. It's because they're extremely poisonous and not much will eat them. In Africa, to survive, plants usually have to have a lot of thorns or be toxic, be poisonous. Another favorite plant of mine is the baobab. If you haven't been to Africa, you must go to Africa. Or as we would say that, you must go to Africa. Because it's the source, it's where it all began. Baobab trees are just so wonderful. And those aren't plants, I'm sorry. Is that it? I guess that's it. Yes, okay. I don't know how to turn this on. So, let's see. There are still a lot of people in the United States particularly who harken back to the days of the end of the 19th century when Americans spoke of manifest destiny, that our race of white people, it meant white people, were destined, it was God's will really, to take over this whole continent, to push out the Native Americans and settle the land with good Christian people. And it was God's will. That's the idea of manifest destiny. But that's closely related to the concept of human exceptionalism. That's the idea of the Anthropocene. We're talking about an ideology that argues that humans are destined to take over the world, and it's a good thing. We see this, we see inklings of this in some of the literature of the Nature Conservancy, I'm afraid. By the way, Dave Foreman, he's a buddy of mine, radical guy, a brilliant historian, by the way, who's coming out with a new book called The Great Conservation Divide, which is about the conflict between the resourcists, the people who see nature as a resource for human beings, and the conservationists who see it as having value in and for itself, intrinsic value. The Conservation Divide from Raven's Press, I'm promoting it. Anyway, the promoters of the Anthropocene are uncomfortable with ideas like beauty and ideas like talking about inherent value or intrinsic value of nature, or uncontrolled, undominated creatures in places. The Anthropoceniacs, which is a contraction between Anthropocene and maniacs, also refer to neatness exemplified by the garden world promoted by Emma Maris and other urban corporate-friendly conservationists. You can see where I stand. Fortunately, though, there are folks like you, naturalists and lovers of native plants and some animals. Your cats and dogs. I have a cat. I love my cat. Anyway, there are people like you who value endemic plant species. But there's other kinds of endemic species like prairie dogs and beavers and coyotes and wolves that have important roles in ecosystem in controlling the damned herbivores that are eating your plants. So it all fits together, as you know. You're all ecologists. So in addition to keystone species, I like the category of foundation species, like aspen trees where I live, that provide so much food and resources and shelter for other creatures, including the understory plants. And in the tropics, one of the most important species is not an animal, it's the fig tree. The fig tree provides food and shelter, ficus, for so many other species, from monkeys on down. So it's all the same, it's all mixed in. We have to love both plants and animals, even if animals shit on our plants. So my first job was in Africa. I graduated from Stanford, and looking around, I wanted to get out of the country. That was the era of the Vietnam War. I hadn't been drafted, but I felt responsible for it. So I just wanted to get away from the politics for a while. So I looked around in Africa and got a job at the University of Malawi, small country. And I learned a lot during that 2 years. I learned some things about myself I didn't like. I won't go into that. But as I said, we were back in Africa last August, and I felt very much at home there, and as I mentioned. And if you haven't been to Africa, as botanists or plant lovers, you should go. If you can afford to ever do it, because the plant life there is just extraordinary and so different than what we see on this continent. Some critics of native creatures say that our preoccupation with native wild things is unfair. They prefer domesticated, rambunctious gardens crammed with non-native plants that are pleasing, safe, and accessible to everyone, and want us to open our hearts to all exotic species, whether invasive or not. What will happen, of course, with that is what I call the homogeny, where every place in the world will be exactly the same botanically. And overall, diversity of plants will decrease because the weedy ones will take over, and the sensitive natives won't persist. Oh, so I'll stop whining about that. So I still believe that wild native creatures have value in themselves and for themselves. And if you believe this, you probably have already answered this question, but can you live in a world lacking wild places and wild creatures? Are you willing to stand up for wild things? Or if you cannot live in a world without wild things, you are what Aldo Leopold called a cannot. You're a cannot if you cannot live without wild things. How many of you are cannots? Great. That's pretty good. So it's important to appreciate yourself for that, to proudly say, I am a cannot. I have a modest proposal that I'll end with, presumptuous. Kids are not going outside these days. When I was a kid and growing up in San Diego, our folks would just kick us outside most of the day, all the time, and we just played outside. We did a lot of damage, some damage in the canyons. But overall, we imprinted it on the habitats that we were in because we didn't have screens to stare at 24 hours a day. So I have a modest proposal. Wherever you live, help kids get outside more. They don't get outside anymore. When they are outside, they're staring at a little screen like that. So is it possible for CNPS to arrange for school kids to get into wild areas? Can you help take children into wild areas? I think that's one of the most important services an organization like this can perform, is help children get outside. I think that's the #1 job for naturalists, to get them stop looking at screens and start looking at plants and animals. It's our sacred duty to do that, an obligation to the future. It's our agenda 2015. Thank you very much. I have a few copies of my anthology of early writings, or not so early, some of them, writings in conservation biology that will be available outside somewhere.